Let us have some word problems concerning power in parallel and series circuits. In our first problem, it asks us to determine the electric power of an automobile headlight for a 12.0 volt source if its resistor has a resistance of 3.60 ohms. In this problem, the voltage and the resistance are both given. From our previous equations, we can choose which among the formula can be used based on what is needed in the problem and the given variables. We can use P is equal to V sub AB square over R, right? Substituting the values where V is equal to 12.0 volts, and then we square it, and the resistance is 3.60 ohms, the electric power of an automobile headlight is 40 watts. Quite easy, right? Try to solve this next problem and let us compare our answer after. A lightning bolt transfers 10.5 raised to 9 joules of electric energy across a 5.65 times 10 raised to 7 volts potential difference for 0.3 seconds. If the net amount of charge transferred between the cloud and the ground is equal to 27.48 coulombs, what is, letter A, the current during the 0.3 seconds, and letter B, the power delivered? I will post this video and try to solve this problem. Okay, let us analyze this problem now. The amount of electric energy, the voltage and the time interval, and the amount of charge are all given in this problem. Again, for letter A, we are asked to solve for the current, which we can compute using the formula I is equal to charge Q over time T. And for letter B, we are asked to compute for power, which we can use the formula V sub AB times the computed value of current, I. Solving for current, we can easily substitute the values. Q is equal to 27.48 coulomb over time, which is 0.3 second. Performing the operation, the value of I is 91.6 amperes. We will use this computed value of current in solving power, which is equal to product of voltage and current. We substitute the values, and the power delivered is equivalent to 5.18 times 10 raised to 9 watts. And that's it. For our last problem, try to consider the circuit shown on your screen. Here, we can see different appliances connected in parallel, each having their own power rating. We are asked in this problem to determine the total current if all the devices are used simultaneously, and B, the total power in the circuit if each device has the same 120 volts across it. Again, I will post this video and try to solve this on your own. Okay, let us check your work. The individual current of each load is given, as well as the voltage across these three appliances. In finding the total current for a parallel connection, we need to add all individual current passing through the load. Therefore, our formula will be I sub t is equal to I sub 1 plus I sub 2 plus I sub 3, which will give us 20 amperes in total. Next, we are interested in finding the total power, which is a summation of total power dissipated in each load. Therefore, we use the formula total power is equal to P sub 1 to denote power in load 1, P sub 2 for power in load 2, and so on. Since power, using Ohm's law, can be computed using P is equal to V times I, then we can expand this formula as this. Now, let us substitute the values. 120 volts times 2 amperes plus 120 volts times 10 amperes plus 120 volts times 8 amperes. You should notice that the total voltage is the same across each load, hence for parallel circuit, voltage is constant. Solving these, the total power in the circuit is 2,400 watts, and that is our final answer. I hope we had the same answers. In case you have questions and clarifications about this, let us know through Microsoft Teams. That is all for this lecture. I am Gilmar De Castro, and see you in the next video.